My name is John Lobell. I teach architecture at Pratt Institute. This is a recording of a lecture for my course on Frank Lloyd Wright, titled Frank Lloyd Wright in the 20th Century. It's a wrapping up lecture where we look at some larger issues. So my definition of architecture is the crystallization of a culture in form. So we derive that from Wright, who says every great architect is necessarily a great poet. He must be a great original interpreter of his time, his day, his age. And Mies says something similar. Architecture is the will of an epic translated into space. So it's interesting when you see things like that and you say, let's take that seriously. What did he mean by that? So what is this world that Wright's interpreting? And of course, it's one of incredible transition. Wright was born into a world of small farms, and Ralph Waldo Emerson's transcendentalism was not something, like for us you might study in school. Wright was 15 years old when Emerson died. In other words, Emerson was a living figure, not some foreign thing. He grew into a world of explosive industrialization: steel, concrete, skyscrapers, telephone, radio, television, automobile, jet travel, atomic energy, and satellites. So pretty much, except for the personal computers, the world that he grew into, the world in 1959 when he died, is pretty much like the world we have today, except for the computers. So let's just look at Wright's work. We're all familiar with that by now. Prairie style in his early work, which becomes the source of the American suburban home, of the ranch house of the 1950s and 60s, asymmetrical, open plan, interpenetration of inside and outside, so the wall opens up to be windows, doing away with the corner, massive chimney core, space floating around that, low-sloped, overhanging, cantilevered roofs, and horizontality. So this is like it's the prow of a ship and this thing's moving across the prairie. So the whole era is in upheaval, in motion. Millions of people moving off the farms into cities for jobs. Millions of immigrants coming from Europe to the United States. The whole world is in motion. And the space moves around and even through the chimney core. New materials, so Unity Temple in Oak Park, in poured-in-place concrete. And Wright, in one of his essays, says, I don't know if anybody realizes this. This whole building is one piece. I mean, you put a building together out of lots and lots of pieces. This is all one piece. Totally revolutionary situation. This crisp rectilinear geometry, abstract. 1920s, the California concrete tile houses, prefabricating the tile and then showing us how it's built. So the construction is a source of the aesthetic. Intermingling the precast tiles with rebars, quarter-inch rebars. So we have two-way slabs. 1930s, Wright had been in a long period without work, and then he gets Falling Water, which launches him into worldwide recognition. Still the sort of open plan, continuity of space, destroying the corner, doing away with the mullion in the corner. Around the same time, Johnson Wax, reimagining the workspace in a modern era. Usonian houses, which are very economical. And then a series of projects in the 1950s, like the Price Tower, based on a 1929 project, St. Mark's Tower. Integrating apartments and office space, responsive to the sun in all different directions, with this sort of core that it's cantilevered out from. Another variant of that, the Mile High, with a central core coming down like a taproot, and the Guggenheim Museum with its continuous flow of space. And series of themes that Wright explores. The most important is the open plan. We see first in 1900 in Ward Willett's house, instead of boxy rooms, space flows from one room to another. So instead of predetermined boxes, which assume predetermined activities, which assumes predetermined roles for members of the family, we have a flow of space, and that continuous flow is representative of the fact that we are continually redefining ourselves at every moment. So, the 20th century. Now, start with new industrial materials. The social critic, William Morris, recognized the impact of industrialization on life, and it was brutal. So, factories were huge, they billowed out black smoke, people worked long hours in dangerous conditions, and as we move into the 20th century, those working conditions greatly improved in some cases. They're still rough in some cases. William Morris said, the machine is the enemy, and proposed the arts and crafts movement. Here he is at his loom weaving. Here is wallpaper that he designed. Here is a Morris chair, which is made by a craftsperson. So he aspires to the medieval craft guild, in which the craftsperson makes the thing, and it's of high quality, the work is rewarding, but what's the problem? And therefore, it's expensive. So yeah, you can get one of these chairs, for a lot of money, but the mass-produced chair is affordable. So in 1901, in an essay called The Art and Craft of the Machine, Frank Lloyd Wright says, William Morris got it wrong. If you put art against the machine meaning the entire industrial culture, the machine's going to win. But really, the machine is, in fact, the art of the 20th century. Now, that doesn't mean all machines are beautiful. What he means is the Greeks used the cutting-edge technology of their time, carving stone and casting in bronze, to make their art. We should not be making our art out of stone and bronze. That's the cutting-edge material of 2,500 years ago, of the Greeks. We should be using the cutting-edge materials of our time, such as cast iron. So Wright fully engages with the industrial materials of his time. And here we see in Unity Temple, poured in place concrete, slip forming. In the Guggenheim Museum, poured in place concrete. Wright's not really that into steel. He uses it, but not in a full-blown way the way he does concrete. Abstract art. Here we are, 1939. Piet Mondrian is about as abstract as you can get. Vertical, horizontal, and the three primary colors, yellow, red, blue. There's yellow here somewhere. But here we are, 1905. That's looking pretty abstract, pretty rectilinear. And in fact, if you look up at the ceiling, here's the stained glass, already looking very much like a Mondrian, except 30 years earlier. So, how should we characterize the 20th century? New industrial materials and abstract art. We see that Wright is fully engaged in those. Now, in addition, loss of a privileged point of view. In other words, we're no longer standing on the earth, which is the fixed, unmoving center of the universe. Now that was already gone with Copernicus, but still we were pretty privileged as a species right up until Wright's time. And a world of stability dissolving into one of change. So here's our world of stability, 1567, Andrea Palladio, Villa Rotunda, and we'll just take this as our archetypal work of Renaissance architecture. It puts the human being in the center. And we know the world from ourselves. We observe with our senses, and we think through with our rational mind. But to observe, you need a point to observe from. So if I say, in terms of perspective, you are twice as far away from me as you, and therefore half as big in perspective, I have to know where I am. Twice as far away from where? From my fixed point of view. And that's what Palladio gives us. The center of an X, Y, and then if we take the Z axis, for us to stand to then measure the world. So the Renaissance borrows from the Greek Gorgias the motto, man is the measure of all things. But if you're going to measure, you have to have a place to measure from. So, throughout Wright's career, this dissolves. When Wright was growing up, the Milky Way was the entire universe. In the 1920s, Hubble, first with the Mount Wilson 100-inch telescope, then with the Mount Palomar 200-inch telescope, discovers that, well, there were always these little fuzzy things in the sky. And the thought was, well, those are gas clouds that are not yet fully condensed into stars. Well, he was able to train a 100-inch telescope on one of those, and oh my God, it's a galaxy made up of billions of stars. And there's billions of them. So that's a pretty severe loss of a privileged position when our galaxy is only one of billions. The loss of fixed time and space. When Wright was growing up, Newton's laws held. Newton said space is a continuous uniform potential which can be occupied by things. Uniform meaning 6 inches here is the same as 6 inches on the moon. Continuous meaning if I have a big enough ladder, I can get from here to the moon. It's all one continuity. It's uniform and things occupy it. Time, there's one giant universal clock. 5 minutes here is the same as 5 minutes on the moon. In 1905 with special relativity, in 1915 with general relativity, Einstein dissolves all that. Space and time are in flux. In special relativity, the sequence of events is dependent on the motion of the observer. In general relativity, the configuration of space is distorted by massive bodies. So what general relativity says, this is standing still. It wants to move, but I'm pushing on it to keep it still. I can even feel its resistance when I'm pushing on it. So it's in motion, and I can feel myself making it in motion. I can feel the pushing on it. Now it's standing still. Space is in a state of dynamic collapse, and this is staying still relative to space. So the Earth is distorting the space-time field around it, which we call gravity. Totally changing the Newtonian point of view, putting everything in flux. And we look at how we are in flux. No fixed center that we can occupy in Frank Lloyd Wright's architecture. When Wright was growing up, painting was still organized by perspective, establishing a fixed point of view. Now here is Degas, who's an impressionist, but absolutely rigorous perspective here. You could construct the vanishing lines, even has a double two-point vanishing. You could construct a model of this exactly. In the early 1900s, Picasso and In the early 1900s, Picasso develops Cubism, and the observer is in motion, seeing the object from numerous points of view. So it destroys the single fixed point of view of perspective. When Wright was growing up, novels were chronological, organized through uniform time. During his lifetime became popular the stream of consciousness novel, where there is not an objective set of events that happen to characters during a set period of time. There's just what's going on in my mind. I'm sitting in this lecture. Got to get back to design. How much longer is he going to go on? Oh, I got to pay attention. What's on that slide? It's just all this chatter going on in your mind. And what Proust and Joyce and Woolf do is follow that chatter. That is what you're experiencing. You can say, I'm sitting in this room between 2 and 3. You can say that. And you can say, well, from an objective observer, from a godlike point of view, would see that that's what we're doing. But what if there is no objective observer? What if there's only you? And you have a certain experience of this, and I have one that's totally different. So that's the stream of consciousness novel. That is, again, like Wright's, my experience coming up the stair and going around here is totally different from your experience coming up the stair and going around here. The building unfolds differently for each observer depending upon their path of motion through it, unlike that Palladio where that building is fixed. No matter what direction I approach it from, it's the same because it's the same on all 4 sides. The loss of human centrality. Now, Darwin published his book in the 1860s, and evolution was sort of being accepted, but the general notion was humans were the favored children of the Creator. We knew we were special. With Darwin, humans are on their own. There is no Creator. We're just one more animal somewhere on the evolutionary tree. And today, now that we understand more and more about DNA, how much of our DNA do we share with chimpanzees? 98%. It's 20% with yeast. A stupid little single-cell animal makes beer. You know, we share 20% of our DNA with yeast, and 98% with chimpanzees, and a lot with everybody else and everything else. So we're just one more creature out there. We're not privileged biologically. When Wright was growing up, the economy was based around the small farm. So there were cities really around industrialization starts taking place in a big way around 1840, and around 1860 it really starts to roll. But Wright was born in 1867, so he grew up on a small farm. Lots of people are on small farms. It's where you got your food. You had to grow it. By the 20th century, the farm became industrialized. Today you have one guy in an air-conditioned cabin of a combine doing the work of what maybe 5,000 people did 100 years ago, or 150 years ago. And so production is on the farm or in the factory, and consumption is in the suburban home. So you don't make anything in the suburban home. You just go to work and consume. Now, there's a term developed by Alvin Toffler of, if you make it and consume it, you're a prosumer, producing and consuming. What's the evidence today that we're becoming prosumers? How many people have heavy-duty automated office machinery in their apartment? Do you have a laptop? I mean, when I was working in architecture offices, there was a room down the hall where they had the Xerox machine and the blueprint machine. Everybody's walking around with them in their backpack, and a billion times more powerful. How many people in your family has an SUV? Anybody? Nobody. Minivan? So the automobile is designed to say, you can't haul hay in this thing. But then when you have a pickup truck or an SUV, it's saying, yeah, I can go to Home Depot and buy a vanity and come home over the weekend and install it in the bathroom, as opposed to calling a plumber and having someone else do it. So with Home Depot, SUVs, home computers and printers, the house, we're no longer in this era. We're in a time of the, moving back to this. Now, not as farms, but your apartment is a pretty heavy-duty place of production if you have a laptop and a printer. When Wright was growing up, there were empires in Europe which liked to see themselves as descendants of Rome. In other words, the Roman Empire was still around. The Roman Empire split into the Eastern Roman Empire and the Western Roman Empire. The Eastern Roman Empire was the Byzantine Empire, which was taken over, became the Ottoman Empire, was still there until the end of World War I. So 1918 was finally the beginning of the end of these empires. So this rootedness in Rome, which was still very much alive, ends during Wright's lifetime. So in the span of Wright's life, so what was happening in 1867? What does that date connote for anybody? 1865, so it's 2 years after the end of the American Civil War. Now, in some ways, the Civil War was pretty modern. I mean, they had instant communications, the telegraph, railroads, machine guns, aerial surveying from balloons, but, it wasn't World War II. They didn't have tanks and all that, So that was really ancient times. And in 1959, I had the list before: satellites, telephones, television, houses with refrigerators, freezers, gas stoves, electric stoves. So Wright lived through this huge span. First house he did had stables in the back for the horses. One of his last projects, Mile High Tower, was a project, not built, was designed to have atomic-powered elevators. So look at the span of development this guy lived through, and played a central role in our engaging with a lot of these developments. So if we look at how Wright was involved with the 20th century, and we take that as, that's the way architecture should be engaged. So what's it like for us today? Architecture is a crystallization of a culture in form. What's going on in our culture? Well, in science, we see it becoming rule-based, so that we're seeing that very simple rules can make very complex things in the software that you use. What's the primary example of simple rules making complex things in the way we understand science? How many letters are there in DNA? 4. Makes all of life. So very simple rules making very complex things. So rule-based science. So very simple formula makes the Mandelbrot set, which is infinitely complex. New materials. So the new Boeing 787, they make it out of plastic, glue the wings on with epoxy. Of course, it's carbon fiber reinforced plastic, so, but totally new materials. What are the implications of this for architecture? New forms of fabrication, 3D printing, which might eventually revolutionize factories. You look at those pictures of thousands of Chinese in Foxconn factories assembling iPhones. People worry about exploitation of the labor. Why will you not have to worry about that in 10 years? It's all going to be done by robots. It's just totally changing everything. You 3D print the parts and then have robots assemble them. Well, yeah, we have 3D printers we use in architecture, but they're kind of make models. They don't make buildings. Well, here's a 3D printed rocket engine that NASA's using. So that's pretty durable material. You can 3D print in metal. You can 3D print in titanium. Yeah, these little titanium particles that the 3D printer lays down, and then laser printers, laser beams weld and fuse them to make the solid thing. BMW has hundreds of 3D printers making parts for their cars. Here's a 3D printer printing a building. It's in Germany. Biotech. So we're now able to read, write, engineer, and recode DNA the way we do computer code. This is the spider goat. Does anybody know about the spider goat? Spider silk is 20 times stronger than steel for its weight. We can synthesize nylon, but we still can't synthesize spider silk. You have to get it from spiders. And the spiders don't like it. You get a lot of spiders that extract silk from, try to milk them for the silk. They get really angry. So what they do is they take the DNA in the spider that makes the silk protein. They put that DNA into a goat. The goat generates the protein in its milk. You milk the goat, extract the protein, and make cables out of it. So we're doing that now. And we can 3D print organs. Here's a urinary bladder. You can 3D print those now. It was really wild when he discovered that you can send human cells through the nozzle in your desktop printer and they survive. You'd think that they wouldn't be too happy about that. So they started with just regular inkjet printers and they put human cells. Oh my God, we could just put a whole surface of skin here. So how do we do it in 3D, and how do we make the nozzles more amenable to biological cells, and they 3D print organs now? Nanotechnology, making things, each of these little spheres represents an atom. So making things at the molecular level. And they envision these little gizmos that go into, and maybe here they're treating, these little robots treating a blood cell. Make these little things go into your bloodstream and scrape out the plaque, stuff like that. How powerful is your iPad? Anybody? How about Infinite? Does anybody use Google Docs? So Google Docs is residing on Google's cloud. So your iPad can tie into the cloud and then harness both software and computational resources. So if you need to do something, like 15 minutes of computing where you need 10,000 computers linked together to do the job, well, it's a lot of work to get 10,000 computers and link them together. Or you just log on to the cloud, pay $20 a minute to use the cloud computing and do that from your iPad. So the cloud changes everything in terms of the availability of computational power. And it's all networked, organized, tied together. And the way things are searchable, networked, are only getting better. Search is in its infancy. So already, Stephen Wolfram, we saw him earlier, has a website that does search called Wolfram Alpha, which is computational. So instead of saying, what's the population of France, you could say, what's the population of France as a fraction of the population of the United States? So Google will just go find a document that's got population in France in it. And hopefully you'll find the answer there. What Wolfram Alpha does is it understands your question, gets the raw data, computes it, and gives you the answer. WolframAlpha.com, it's right there. Anybody used it? It's available. It's another search site. And this stuff is just beginning. And then, so what's the implication for architecture? So you see all those models down the hall in the basement, that's Haresh Lavani, who works in 27 dimensions in the morphological universe. You can move through there, find all form, human-made and natural-made. He uses that in doing his architecture. Carl Shu, anybody been in Carl's studio? Carl gives his students 3 genes. At the beginning of the semester, by the end of the semester, the building has grown itself based on the rule sets of these 3 genes. So we're in an era of technological explosion, just the way Frank Lloyd Wright was, totally different technologies, and just the way Frank Lloyd Wright understood and embedded that in his architecture, that's what the architecture of our era will be called on to do. So keep your eyes on who you see out there who you think might be actually doing that.